So today we start with limits part 2. I tell 2 or 3 theorems, some sums, then done. Okay, then let's begin. Now there will be one theorem I'm going to tell you. The number I don't know what number theorem it will be. I'm not going to tell you the general case, but show it like an example with you. Okay, let's say I have this sum. Limit x tends to 2, x cube minus 2x square by x cube minus 5x plus 6. So what you will do is you will just input the values here. You will see that the above thing comes out to be, let's say, 8 minus 8, that is nothing but 0. Okay, 0 can be at above. Here let's put 2. We'll say 4 minus 10 plus 6. Isn't that 0? So the case becomes a 0 by 0. So whenever such a polynomial function, okay, let me erase this. Whenever such a polynomial function, this is nothing but sum f of x, sorry, 2x square. So this thing is nothing but sum f of x that can be represented as g of x by h of x. How to solve such kind of things? First, you have to factorize it. If you factorize the above part, you will get what? X is, one second, let me write this, x square by x minus 2 by x minus 2. I'm not showing the factorization, you can understand on your own. X minus 2 into x minus 3. So this and this get cut. So my new thing is x square my x minus 3. So now limit 1, told you, like, limit, if this is f of x, limit of, remember, limit of f x tends to a, f of x is nothing but f of a. So my limit will be nothing but 2 squared by 2 minus 3. So that is nothing but minus 4. This is how you solve these kind of sums where 0 by 0 comes. Understand this very clearly. Without understanding, we can't proceed. So the next theorem we're going to learn, one second, let me write the theorem well. The next theorem we are going to learn is this: if limit x tends to a, x to the power n minus a to the power n by x minus a is nothing but equal to n into a to the power n minus 1. How is this possible? Just joking, let me try to do this. What is x to the power n minus a to the power n? It's nothing but x to the power n minus 1 plus x to the power n minus 1 n minus 2. Let me rewrite this, n minus 2a plus so on till a to the power n minus 1. This into x minus a whole divided by, I'm doing x minus a. So this gets cut. Understand? Now this becomes my function, means this is my f of x. So f of x, I'll put the value of a in it. So what will be the value? See, a to the power n minus 1 plus a into a to the power n minus 2, and so on it will go. So n times of it will occur. So n into a to the power n minus 1. This is my theorem here. Very clearly you understand this. Let me show you the theorem once again. This is the theorem. Remember it, very useful. Let's try to do one sum in using this theorem. Let's say I give you limit x tends to 1 x to the power 15 minus 1 by x to the power 10 minus 1. You would say, see, it is coming 0 by 0. Sometimes these things come 0 by 0. Then how to do this? So now this term I can break it as x to the power 15 minus 1 by x by 1 divided by x to the power 10 minus 1 by x minus 1. Cannot I write that? And I told you limits can be broken into two parts. So I have to find the limit of, okay, let me change the color. So I have to find the limit of this part, then find the limit of this part, then I'll divide it. Understand? So the limit of that part will be how much? 15 into 1 to the power 14 divided by 10 into 1 to the power 9. Okay, using that the theorem we just learned now, so what will we do? So this becomes nothing but 15 by 10. What is 15 by 10? 3.2, that is 1.5 for your kind information. So we learned how to solve this. Okay, this is let's do one more sum before wrapping it up for final. We'll do one more sum before wrapping it up. Let's say I will do with a theorem only. Let's say okay, let's do this. Limit x tends to 1 x square plus 1 x minus 1. As you can see, above it is 2, so it is coming 2 by 0. That is wrong, not working. So how to do this sum? So you can do it like this. You break it x minus 1. So we will do with the earlier method I told you, the first thing we told you. You have to break this down. Okay, no, this is not x plus 1, sorry, this should be x minus 1. X plus 1 we'll do later. This thing you can do it by both the theorems. Okay, so let's do by theorem 1 first, theorem of 1 of today. So what can I do? The above part I can add x plus 1 into x minus 1 by x minus 1. So this gets cut, this gets cut. You put 1 in its place, the answer comes out to be 2. This is by theorem 1. But now if we do by theorem 2, what did I tell you about the theorem 2? That whenever this x square minus 1 by x, so what will happen? 2 will come in the front to the power 1 to the power 1. 2 minus 1, that is 1 only. Okay, 1. So this becomes 2. So my answer is correct. This is one sum where you can implement both the methods. Understand? Now I think I will, one second. So this is the end of the video today. So bye, meet you the next time.